Hi, I'm Mrs McTaggart and this is lesson 2 in angles in a circle. In this one we're going to be looking at isosceles triangles. You should have already maybe met the lesson on finding right angle triangles within inside a semicircle. If not, it's okay, they can be interchangeable. So when you are looking at circles, here's a new word for you. The new word is chord. Now chord is a special line within a circle. It is the line if you were just to take a slice off the circumference. So this blue line here would be a chord. Alright, and this red line is a chord. Whenever you have a chord and you join it from either side of that back to the centre, these two sides are both obviously going to be your radius. So radius is always a line that goes from the centre to the outside of a circle. And if they're both radiuses, then you have isosceles triangles. So always look for, at the start of questions, look for any lines that are radiuses, put a little mark on them, and then hopefully you'll see some isosceles triangles jumping out at you. Isosceles triangles, remember, have symmetry, that the two sides, the two angles on the left and right will always match. And there's two different methods. Sometimes you'll get this angle first, you then duplicate it to get that one, add and take away from 180 to get that one. In reverse, if you're given the top one, you still take off from 180 and then you split it in half to get these two. So depending on the scenario you're looking at, there's the two different methods. But you should have met them during BGE in first or second year. Okay, so filling in the missing angles. So first off, as I said, remember we're looking for radiuses. So there is a line from the centre to outside. There is another line from the centre to outside. So I have an isosceles triangle going on here. To get the two missing angles, we're going to do 180, take away 120. Keep the numbers nice and simple, so that gives us 60. So that means that these two angles here make 60. So you do 60 divided by 2, and that gives you 30. So these two angles here are 30. And it's always worth a quick check that they always should add back to 180. So they're both 30s. And I should technically put in my degree signs, but it's a bit difficult using the iPad here. Okay, second one, let's look for radiuses. So here is a radius from the centre to outside. Here is another radius from the centre to outside. Now this line here is also a radius, but it's not part of a triangle, so I'm not going to bother marking that one on, okay? Right, let's fill in our missing angles. So these two are on a straight line. So my first sum is going to be 180 take away 140, which makes this one in here 40. And then 180 take away 40, we've just kind of done the reverse sum. We've got 140. So these two angles here make 140. So half 140 gives you 70 and 70. So these two angles are 70 degrees. That's us filled in all the missing angles. Okay, one more. We're building up to the more exam style questions. Now in an exam there will be letters on the sides of these triangles and it will tell you which angle you're trying to find, but I'll leave that until the end when we're ready to do the past paper questions, and there'll be another video on that later on if you want to watch. Right, so task 1 is always look for radiuses and right angles. So here is a radius. I'm going to just make my radiuses green. Here is another radius and here is another one. So I actually have two isosceles triangles, but these two triangles put together, I don't know if you can see it, create a right angle triangle within a semicircle. So there is a 90 degree angle up here in this corner. Now sometimes in the exam there is a mark for recognising that that is a 90 degree angle. Okay, right, let's fill in some missing angles. The first one I'm going to get is this one here. So it's on a straight line of 145. So 180 take away 145 leaves you with 35 in here. Of course this is an isosceles triangle, so these two match. So this is also 35. Right, I now have two places to go. I can either go find this angle or I can go find this angle. We all work slightly differently. If you didn't spot the 90, you probably wouldn't go for the one up there next. But I'm just going to show you that all angles will come back to give you the same, depending, no matter which method you go. My instinct is always to finish off the isosceles triangle. So 35 and 35 is 70. 180 take away 70 leaves you 110. So this one here is 110. Now, of course, that 110 is on a straight line, so these two here must make 180. So 180 take away 110 is 70. And then we have an isosceles triangle again, so these two match. 180 take away 70 we know is 110. Half of 110 is 55. So this one and this one are 55. Okay, now I did say there was another method to go, so I'm going to quickly just retrace my steps a wee bit, and I'm going to go back to this one here where we didn't have that in, and then I could say that, well, 90 take away 35 makes that one up there 55. Using the isosceles triangle, this one here is also 55, which is 110, still leaving this one with 70. So it doesn't matter which like kind of order you go round in, you should still have the same answers as long as you've done all your calculations correct and not misassumed any right angle triangles or anything in the wrong places. Okay, so this is getting more towards an exam one. And then what I've got as usual is I've got some questions for you to try on your own. If you wish to pause the video, you can try these. When you are finished, if you unpause, the answers will all be there. So there are your answers as well. I hope this has helped. Thanks for watching. Come back. The next video is going to be on tangents, and then there'll be some past paper questions.